Hello and welcome to my kubectl Introduction for Console Hackers talk. My name is Lucas, I'm a developer at .finis and I do open source software by night. You can reach me at my Twitter or contact me by email. The company I work at .finis, has been in the market since 2000. We have offices all over Switzerland as well as in the Netherlands. We are over 70 employees with a broad customer base, and we do 100% open source following the open philosophy. We do engineering, managed services, DevOps, and development. And in this talk, I'm going to focus on kubectl, which is the Kubernetes API client, so it's going to be squarely in the DevOps camp. Like I said, kubectl. Kubernetes is the de facto API to interact with cloudy container-based infrastructure, like for instance a SUSE CaaS Platform, and we need a handy tool to drive that API. Per default, Kubernetes ships with a tool called kubectl. In this talk, I'll be showing you how kubectl works and what it can do. Well, the first question that we always have, maybe this is a bit of a dead meme already, but how do you pronounce kubectl? We've heard kubecontrol, kubectl, or kubectl. Personally, we like calling it kubectl because it's just as fluffy as the clouds we are deploying to. While Kubernetes users mostly use kubectl, the users of Cloud Foundry-based solutions would use the CF command line client. There are a few differences, like kubectl is a low-level Kubernetes client, whereas CF is more of a high-level client. Kubectl can manage a lot of aspects of a Kubernetes cluster, while Cloud Foundry just focuses on having a command line experience to help deploy stuff. You need to do some learning if you want to master kubectl, but with CF, it's a much less high learning curve and you can really get started quite easily. A CF would be what you use if you had a SUSE CaaS installation. But in this demo, we'll be focusing on kubectl on a SUSE CaaS. This was originally an interactive presentation. We had to strip out lots of the interactivity for the SUSECON Digital. But we still left in some fun quizzes. There will be a couple of quiz time slides throughout this presentation. Feel free to follow along. I'll be showing the right solutions all the time. But you can count how much things you get right and then tell us later, for instance. In this case, how do you pronounce kubectl? Well, there's lots of different pronunciations. There's certainly no canonical way to pronounce it. Personally, I prefer kubectl, but you may have already noticed that I end up switching how I pronounce it a lot of time. How does this client interact with the API server from Kubernetes? It's REST, following using either JSON or protobuf as the wire protocol. Authentication, like when you get a cluster, you need to authenticate to it. In most cases, well, in all cases that we actually use in productions, we assume that users are managed by an outside independent service. This could either be an admin distributing private keys that are tailored to your cluster. You could hook up your cluster with a user store like Keystone or Google accounts, or you could just manage a file with a list of usernames and passwords. To log on to the cluster, you can run any command when you're not authenticated to the cluster, and Kubernetes will basically do the right thing and just auth you. We personally like using the command kubectl cluster-info to log on to a cluster, because then you not only see if authentication works, but you also get some basic info on the cluster. In our demo, I'll skip the auth part. The demo cluster I'm using on is based on pre-shared configs, and I'm prepared to just use that. So in my case, my admin already gave me a YAML file, and I can just use that to auth. Let's see how this all works. Let's see how this all works using Kubernetes cluster info. First, I load the YAML file I was given by my admin into the kubeconfig variable. And then I can do kubectl cluster info. I can now see that there's a master running, there's a DNS system running in the cluster, and there's also a dashboard running. To further debug and diagnose cluster-wide problems, I could also do kubectl cluster info dump. This shows way more info. It's dumping logs on all the cluster components, and it really helps if you have an issue and don't know where to look. You can just do a dump and then analyze that dump for info. We can also use kubectl to inspect the API. I could ask for API versions. Oops. And this will output all the different namespaces where, well, namespaces is actually a bad word. This will output all the different pseudo-DNS names where I could find parts of the cluster. Apart from using versions, I can also do kubectl API resources. And this shows me all the different things that I can provision using the manifest with the kubectl API. If I want to know more about a specific thing, like I would like to know how exactly a pod looks like and what kind of field it allows, and I can do this by explaining the pod. I want to add recursive equals true, so I get the fully deep dump of all of the pod. This is quite a lot of information, but I can really look at this and I can see what kind of objects are underneath, like the status part of a pod. And with this I can inspect all the things that I got returned when I did an API resources call. Just for those who haven't done much Kubernetes, you'll be hearing the word pod a lot. Pods are a group of containers that are deployed together on the same host. Now for another quiz. There are quite some API versions. I've added a list here, and it's up to you to guess which of these are part of a default Kubernetes installation if no additional tooling was installed. Naturally, the monitoring.coreos.com, which is part of the Prometheus operator, isn't part of a default Kubernetes installation. Also, the OpenStack one isn't part of Kubernetes as well. That's something you would see in other clusters. How can you figure out what parts of the API do what they support? In this case, there's only one correct answer, and that's using kubectl explain. Often you'll want to look at the reference documentation online instead of trying to figure all this out using the command line. We did an API versions and API resources call to figure out what kind of resources are available. Now let's look into how we can get and describe these resources. We have cluster-wide resources like nodes, where we can use kubectl get nodes to get a listing of the available nodes in this cluster. In our case here, we have one master node, which is the API control plane, and we have one worker node, which runs the actual pods that were scheduled. We can also get other things like services. With the -big A, we're getting services throughout all the namespaces. So here we'll see some services that are in the default namespace, but we'll also see the system parts, as well as other things that have been deployed to this cluster. If you want to see information, like for instance about the master node, you could do kubectl describe node and the name of the node, and then you get quite some information on the node, how many RAM it's using, what kind of memory what kind of CPU allocations it has, and also what's running on the node. This kubectl describe command also works for other things. So I can just go and describe a pod called Stratos 0, where the Stratos web interface is running in. Naturally, I need to specify the namespace where it's running in, because my current namespace isn't the Stratos namespace. But using this, I can get quite some information. I can see all the environment variables that were set on this deployment. I can see the kind of volumes that were mounted. And right at the bottom here, I also see events that were generated by this cluster. This will help when we start debugging if something doesn't work as intended. Always, we can add -o YAML to look at the YAML representation of things. So let's do this on this pod. We need to get a pod and then can do -o YAML. And now we can see the YAML output, which looks pretty similar to what was deployed, but additionally has stuff like status inside. kubectl also supports a bunch of other output formats. You can also dump JSON. There's various ways where you can either use JSON path or a Go template to only return parts of a YAML representation. So, how can you look up pods? There's a few ways that I'm proposing here. Take your time to figure out which one of these are the actual ones that work. It's only the last one. First, we do kubectl, then we get a pod, and we also need to add a pod name if we would like to get info on just one pod. An alternative would be kubectl get pods, which would just return all the available pods in the current namespace. Next quiz question is, what kind of output does kubectl describe actually display? Think about it for a bit. Should be an easy one. It only shows the state of resources with some additional info. So no YAML for a describe, and also not something similar to top. Now we looked at how you can look at stuff that's running in the cluster. Let's also look into how to apply new stuff to the cluster. You can create in-cluster resources from a local YAML file. Let's assume you have a pod definition that looks similar to this. You can already see that the image path inside is invalid. So I'm just gonna show you here again, and then I'll do a kubectl apply -f on this file. And now let's look at what we just deployed. Using kubectl get, I can get all the pods. And you'll see down at the bottom here, there's one pod that has error image pull. Let's just look at that pod. Yeah, now it's doing image pull back off. So clearly there's something wrong. If I'd like to figure out what's wrong, I can do a describe on the pod. And I can now see that it's having issues with pulling the invalid image, which is rather expected because the image is rather invalid. Now you might ask, how would we fix something like this? Well, you can use kubectl edit to edit any resource in the cluster. This is a quick and rather dirty way to edit resources. We recommend only using it for debugging, because in the end of the day, Kubernetes should not be the source of truth for everything you configure inside it. Anyway, we'll just edit this pod that we deployed earlier. I can now scroll down to the invalid image path, remove that and replace it with an image path that actually points to an existing container image. In this case, it's on Docker Hub. Now I can describe the pod again, and now we see after the old events, which were a while ago, were replaced with a successfully pulled image event with a created container event. And if we get the pod again, we can now see one of one containers is ready, it's running. It restarted once while I was fixing the image. And that's how we, whoops. That's time for our next quiz. How can you add resources to your cluster? We have kubectl get, apply, import, and load as options. And like I just told you, the proper option is apply. Should you use kubectl edit on production? Lots of choice here. All of them that say no in various languages are right. Just don't use kubectl edit on production, it will only hurt you. Next up, we'll look at scaling some stuff in this cluster. First, let's have a look at all the things we just deployed in Stratos, the Kubernetes UI. This is our Stratos installation. We can see how many pods have been scheduled, and if I go down to the pods, I can filter for my pods pod, and I'll see that it is one container. I can see it's running. I can see how much is ready. Basically the same information I saw with kubectl get. Now, since we directly deploy the pod, I won't be able to scale it, but what I can scale and what I'll be doing is scaling up Stratos. If we search for Stratos in the Stratos UI, we see the database and the main container of Stratos, which is running. And I can now use kubectl scale -- replicas equals 2 on the stateful set / Stratos resource, which tells me it was successful quite fast. Let's get the pods to see if they were actually scaled up, and we can now see there are now 2 Stratos pods, Stratos-0 and Stratos-1. I can reload in the Stratos UI itself, and I can now see that Stratos is now more redundant than it was before I clicked here. So that was scaling. Scaling works for deployments, for replica sets, and for other resources that have a replica count field. Now for a smallish quiz on the whole scaling, what does the replica argument actually specify? Is it A, the number of target replicas, or is it how many replicas to add to a given deployment? Naturally, it's the target number of replicas. Now, we earlier looked into how to find out if a pod isn't working with kubectl debug, with kubectl get and describe. Let's look into how you would debug an application running on a CASP. First of all, you can usually look at the standard error and standard out logs of a pod using the kubectl logs command with a pod name. So let's do that. You can see the server is ready to handle requests. This is just what this pods thing is logging. It's actually a Go application for those that realize this. So this one isn't logging much. We can assume it's working, so there's not much to say. What we can also do is run commands, for instance, an interactive shell inside of a running pod. Let's try doing this on this pods pod thing. kubectl exec pods pod space shell will tell us that it caused an error. sh wasn't an executable file in the path. In this case, it's a case of the application in this pod being a very simple from scratch application that just contains a basically very large application binary but no other user space. So if you really want to execute a shell in a container, we would need to grab one that actually has a shell inside. For instance, the Stratos container we looked at earlier. Demo time. I guess it doesn't want to be. Let's just execute something in another container somewhere here. Like for instance, we could do kubectl exec dash terminal dash interactive on blah. Let's just grab the kube scheduler. Voila, we now have a shell inside the kube scheduler pod. We can do regular PS stuff to figure out what's running. We could also run commands like top if we need to figure out anything else. Once we're done doing stuff in here, we can just use exit to get out of the container again. Coming up in newer Kubernetes releases, there will be a kubectl debug command that helps you spawn a sidecar container in the same context as a pod. You could, for instance, use this to debug an example like the pods container I was using earlier, which doesn't have a shell of its own. So you would then create an additional container with a shell inside that just gets deployed into the same system namespace as the pod you are trying to debug. Another way to quickly figure out if something is wrong is to just delete a pod that was scheduled by a deployment or stateful set, and the cluster will recreate it. Let's try this by deleting the second Stratos instance I deployed earlier. It has now been deleted. And I can now get pods again, and what I can see is, well, maybe in the proper namespace, and what I can see is that it's still terminating this Stratos-1 container. But if I watch this for a while, we'll see pretty soon after it's done terminating that there will be a new one started. This is also something we can look at inside of the Stratos UI itself. You can see now that it's gone to state pending, and there's like 0 of 3 containers that are ready, which actually matches what we're also seeing here on the command line. It's now in state container creating, and I can really like switch back and to from this, and we can see that the state is always matching. So, as a quiz, what kind of commands would you use to debug the state of your application? Kubectl logs, describe, exec, or why though? I'll solve for you. The first 3 options are actually fine to figure out how stuff is running. Okay, let's move on to storage. Usually you'll want to deploy some volumes you want to use some volumes in your application deployments that are running on Kubernetes, and you'll do these through 2 things called persistent volumes and persistent volume claims. You'll tell the cluster that you want a persistent volume by creating a persistent volume claim, and this will then be fulfilled by a storage class that actually creates a persistent volume that you can then attach to your container. Let's have a look at the PVs, persistent volumes, and PVCs, persistent volume claims, that are already available in the cluster. We can do this by just writing kubectl get PV, and we'll see 3 PVs that are part of the Stratos deployment that is running in this cluster. We can do kubectl get PVC-A to get PVCs over all the namespaces in the cluster, and we can see matching claims for each of the PVs we earlier looked at. Next, we can also look into the Ceph admin, and we can see there's 3 different Kubernetes dynamic PVC things that were created automatically using the Kubernetes API, but the actual disks were provisioned on Ceph. Next, we can actually create a new PVC by using kubectl apply on a file that defines such a PVC. Let's look at this file. It's a very short file. We just define an access mode and we define how much storage we want. In our case, it's going to create a block disk that is 1 gig large. Let's just do kubectl apply-f pvc.yaml. We can now see it was created. Looking at the PVC, we can see a new PVC called myClaim in the current namespace. And we can also do kubectl get PV. And then we can see there are now 4 different PVs that were bound. Back in Ceph, we can reload this and we can see that there are now 4 volumes that have been created in SUSE Enterprise Storage. With which commands would you interact with Kubernetes storage? Would you use regular commands like kubectl get, describe, and edit? Would you use lvchange, mkfs, and dd? Or would you use kubectl storage get, patch, edit commands? It's quite simple in this case. You would use regular commands like kubectl get, describe, and edit. Like everything that's in the Kubernetes API, you just use the same kubectl tooling to interact with all of it. Next up, we'll have a short excursion talking about Helm. Helm is the de facto standard package manager for Kubernetes resources, and it directly interacts with the Kubernetes API. SUSE has put lots of work in making Helm a first-class citizen. We could have a look at how Helm is in Stratos, but that would be outside of the scope of this talk, so please go watch a talk about the Stratos UI. I'm sure Troy or someone else from the Stratos team has an awesome talk on this SUSECON on this. Let's redeploy the pod from before again, but this time we'll be using Helm with a Helm chart we wrote to deploy that actual pod. I can just do Helm install a name for the deployment, and then I specify a chart name. In our case, it's atfinis/Casperly. Atfinis is our chart repository that contains packaged Helm manifests for you to use, and we want the specific Casperly chart inside of that. This takes a while, and then I get information that everything was deployed. And I can now do a kubectl get pods using the information that it was deployed with to get some stuff. I can see, for instance, that the pod is running, or I could also do get all, and I would see that this now consists of a couple parts. We have a deployment, we have a service, and all of this I can also go back to the Stratos user interface. I can select pods, and if I search for Casperly, like I called the thing, I can see that it's running in the namespace kube system and on the worker node, which we inspected earlier. One thing to note is if you do a get all, it doesn't actually return all the resources. The get all command is still available, but it has been decided that we shouldn't be using it, so it doesn't learn about new resources. So in reality, don't really use get all. Now for a small quiz about Helm and kubectl. How do they differ? Do Helm and kubectl do the same thing but have different semantics on their command line? Is kubectl a native Kubernetes command line client while Helm uses the API without using kubectl? Does Helm drive kubectl to deploy YAML manifests, or is kubectl a wrapper to run Helm, where Helm does the heavy lifting? Are both tools written in Golang? Let's see how many you guessed right. Actually, in this case, it's only one thing that is really an important distinction that makes these different. So all the other points except the second one aren't describing differences between Helm and kubectl, but are describing stuff that they both do similarly. We're almost at the end of this awesome talk. Now for a tally time. We had some quiz questions throughout the talk. I hope you all got your answers right and were honest in counting your answers. Please let us know how many of the questions you got right. You can tweet us your results to @Finis using the hashtag SUSECON Digital 2020 hashtag. Thanks for your interest. I hope I was able to talk to you a bit about the kubectl client, hoping that you'll be able to use it on a SUSE CaaS platform near you soon. May the cube be with you.